Okay, so today we're going to carry on looking at tree diagrams, and we're just going to run through a couple of examples of sort of worded questions that you might be asked, and then there's some questions for you to have a go at. So, example 1, we're told bag 1 contains 5 blue sweets and 4 red sweets. Bag 2 contains 7 blue sweets and 3 red sweets. Draw a probability tree, and then we're asked to calculate some probabilities using it. So in bag 1, there are 5 blue sweets and 4 red sweets. So the probability of picking a blue sweet, well, in total there are 9 sweets and there are 5 blue sweets. So the probability of picking a blue sweet is 5 out of 9, and the probability of picking a red sweet is 4 out of 9 because there are 4 red sweets here. Bag 2 has a different number of sweets. So there are 7 blue sweets and 3 red sweets. So there are 10 sweets in total. The probability of choosing a blue sweet is 7 out of 10, and the probability of picking a red sweet is 3 out of 10. And so that would be your completed tree diagram for part I. I'm just going to try and get that a bit more in focus for you. Hopefully that'll help. Yeah, well, okay. We're then told Ben chooses a sweet from bag 1 and a sweet from bag 2. Calculate the probability that he picks 2 different colour sweets. Well, to pick 2 different colour sweets, he is either going to pick a blue and then a red, or a red and then a blue. So these are my 2 options. And remember, we multiply across. So to pick a blue and then a red is 5 over 9 times 3 over 10, which is 15 over 90. To pick a red and then a blue is 4 over 9 times 7 over 10, which is equal to 28 over 90. And so if we just represent that here to calculate our final answer, so the probability of 2 different is equal to the probability of a blue and then a red plus the probability of a red and then a blue, which is equal to 15 over 90 plus 28 over 90, which is equal to 43 over 90. Part B says find the probability that Ben picks at least 1 red sweet. Now there are a few different ways that you can do the at least questions. For him to pick at least 1 red sweet, he could pick 2 blue, he could pick to pick at least 1 red sweet, he could pick a blue and then a red and then a blue, or a red and then a red. So he could pick any of these options apart from 2 blues. So he could not pick that one. So either I can find the probability he picked a blue and then a red, plus the probability he picked a red and then a blue, plus the probability he picked a red and then a red. I could do that and multiply across here and then add together. Or you can say that he could pick from any of these 3 options, and there's only one that he could not pick from. Now remember, all probabilities add to 1. So I could say that the probability he picks at least 1 red sweet is 1 minus the probability that he picks 2 blue sweets. Okay, so both of these ways work. So I'm going to do the 1 minus probability he picks 2 blue sweets. Now the probability he picks 2 blue sweets is 5 over 9 times 7 over 10, which is equal to 35 over 90. So using this in my solution down here, the probability that he picks at least 1 red sweet is 1 minus 35 over 90, which is equal to 55 over 90. If you'd have felt more comfortable finding the probability he picks a blue and then a red, which we've done here, a red and then a blue, which we've done here, and then doing red and adding those together, that's absolutely fine. It'll give you the same answer. This way is just a bit quicker and means you're less likely to sort of make little mistakes on that one. So what I'd like you to do now is, using that example, have a go at the your turn question, which says Sarah plays chess and wins with a probability of 0.3. She then plays Monopoly and wins with a probability of 0.7. Draw a tree diagram. So pause, have a go, and then we'll run through it. Okay, so the first thing I'm going to look at is when she plays chess, and the probability that she wins here is 0.3, which means the probability she does not win is 0.7. Then she plays Monopoly, and we're told that she wins that with a probability of 0.7. So now the probability of winning 0.7 and the probability of not winning is 0.3. Because we've titled these under the different games with the different probabilities. So the first thing I'm asked to calculate is find the probability Sarah wins both games. So she wins chess and she wins Monopoly, so we've got 0.3 times 0.7, which is equal to 0.21. So the probability that she wins and then wins is equal to 0.21. The probability that she loses both games, well here that means probability of not winning chess and then not winning Monopoly, and so that is equal to 0.7 times 0.3, which also gives you an answer of 0.21. And then we're asked to calculate the probability that she wins at least one game. Now remember what we looked at before, that means that she could either win both, she could win and then lose, or she could lose and then win. So I could calculate all of these probabilities, or I could do 1 minus the probability that she loses both games. I've already actually calculated this probability in part B, so I can just use that to help me. And 1 minus 0.21 is equal to 0.79, and that would be your answer there. You would get the same answer if you completed these and added those together, so you should get 0.79 there. Using those, have a go at the practice questions for today. And as always, feel free to email me if you have any questions or aren't sure about any of those things there.